The UK and Australian military have unveiled their latest advancements in combat technology, a new generation of combat drones and AI robots designed to dominate the battlefield. As global tensions escalate, these technological marvels are poised to redefine modern warfare. They exemplify the military power and innovative spirit of both nations, demonstrating their readiness for war at any given moment. Stay tuned to see how these shocking developments could shape the future of combat. Developed by Boeing Australia in partnership with the Royal Australian Air Force, the MQ-28 Ghost Bat is designed to serve as an unmanned wingman to manned fighter jets. This innovative approach provides enhanced tactical flexibility on the battlefield. One of the standout features of the MQ-28 is its versatility in mission profiles, capable of executing air combat operations, surveillance tasks, and electronic warfare. The drone's design is highly modular, allowing for the integration of various payloads such as sensors and weapons, which means it can be tailored for specific missions ranging from reconnaissance to offensive strikes. Furthermore, the MQ-28 Ghost Bat incorporates advanced artificial intelligence that enables real-time decision-making and autonomous mission execution. Stealth is another critical aspect of the Ghost Bat's design. The aircraft is built with features that minimize its radar cross-section, making it difficult for enemy radar systems to detect and track. This stealth capability, combined with its speed and agility, ensures a higher survival rate in contested environments where air defenses are robust. The Protector RG MK1 is a next-generation unmanned aerial vehicle developed under the UK's Reaper replacement program. The Protector is designed to provide the Royal Air Force with a flexible, multi-role platform capable of conducting a variety of missions, including ISR and precision strikes. The Protector is notable for its ability to operate in both military and civilian airspace, a feature that extends its versatility beyond purely military applications, allowing for use in border surveillance, disaster response, and other peacetime operations. One of the standout features of the Protector is its extended endurance, which allows it to remain airborne for over 40 hours, depending on the payload and mission parameters. The drone is equipped with advanced sensors, infrared cameras, synthetic aperture radar, and signals intelligence systems, enabling it to gather detailed intelligence and conduct precision targeting in all weather conditions, day or night. The Integrator System, developed by In Situ Pacific Australia, is a versatile UAV designed for ISR missions. This UAV system is an evolution of In Situ's Scan Eagle platform, known for its reliability and effectiveness in providing real-time intelligence to military and civilian operators. The Integrator builds upon this foundation, offering enhanced payload capacity, longer endurance, and improved data collection capabilities, making it ideal for extended operations in diverse environments. With a wingspan of approximately 5 meters and a maximum takeoff weight of 74 kilograms, the Integrator is capable of carrying multiple payloads. A key feature of the Integrator system is its modular design, which allows operators to quickly swap out payloads and adapt the UAV for different missions. This flexibility is crucial for modern military operations, where the ability to rapidly adapt to changing conditions can provide a significant tactical advantage. Efficient mission planning and execution. The DragonFire Laser Drone Defense System is an innovative directed energy weapon developed by the United Kingdom to provide a robust defense against unmanned aerial vehicles and other airborne threats. This system represents a major advancement in counter-drone technology, leveraging high-energy laser beams to neutralize targets with precision and speed. Unlike traditional kinetic weapons that rely on bullets or missiles, DragonFire uses a focused laser to deliver energy directly to the target, causing it to overheat and malfunction or be destroyed. This approach offers several advantages, including the ability to engage multiple targets in rapid succession without the need for reloading or resupply. One of the most notable features of the DragonFire system is its accuracy. The laser can be precisely aimed at small, fast-moving drones, effectively disabling them at ranges that are challenging for conventional anti-aircraft systems. The BAE Systems STRIX Drone, developed in collaboration with the Australian defence sector, represents a new frontier in autonomous aerial warfare capabilities. While much of the detailed specifications of the STRIX drone remain classified due to its cutting-edge technology and sensitive military applications, what is known paints a picture of a highly capable unmanned aerial system, UAS, designed for a range of combat and support roles. One of the key features of the STRIX is its stealth design, which minimizes its radar cross-section, making it more difficult for adversaries to detect and engage the drone. In addition to its stealth capabilities, the STRIX is equipped with a range of sensors and systems that allow it to perform multiple roles on the battlefield, from ISR missions to direct combat operations. Furthermore, the STRIX utilizes advanced AI to enhance its autonomous operational capabilities. This includes the ability to make real-time tactical decisions, navigate complex airspaces, and engage targets with minimal human intervention. The SMASH-X4 fire control system is a state-of-the-art weapon sight system developed to enhance the capabilities of small arms against airborne threats, particularly drones. Designed by SmartShooter, a UK-based company, the X4 integrates advanced computer vision technology with small arms to significantly increase the accuracy and effectiveness of soldiers in the field. The system uses sophisticated algorithms to detect, track, and lock onto moving targets, automatically adjusting the aim to ensure a higher probability of a hit, even against fast-moving, agile drones. This technology transforms conventional firearms into smart weapons, allowing ground forces to effectively engage and neutralize small UAVs that may be conducting surveillance or carrying payloads. Additionally, the X4 can network with other systems, allowing for coordinated defense operations and enhancing situational awareness across units. The Drone 40, developed by Australian defense technology company Defentex, exemplifies a new generation of compact, loitering munitions designed to offer flexibility and versatility in modern combat scenarios. Unlike traditional drones, which may serve purely reconnaissance or strike roles, the Drone 40 is a hybrid system that combines the characteristics of a drone with those of a guided missile. This loitering capability allows it to hover over a battlefield or specific target area for extended periods before striking, making it ideal for dynamic combat environments where targets are not always immediately identifiable. The Drone 40 can be deployed from a wide range of platforms, including handheld launchers, ground vehicles, and other UAVs, providing significant operational flexibility. One of the primary advantages of the Drone 40 is its ability to carry various payloads tailored to specific missions. These payloads can include explosive warheads for direct strikes, cameras for surveillance, and electronic warfare systems to disrupt enemy communications and radar. The Taranis, developed by BAE Systems, is a groundbreaking unmanned combat aerial vehicle that embodies the future of stealth and autonomous warfare technology. The development of Taranis reflects the UK's commitment to maintaining a technological edge in modern warfare. The drone's design prioritizes a low radar cross-section, enabling it to penetrate defended airspace undetected and carry out reconnaissance, surveillance, and strike missions in highly contested environments. This stealth capability is further enhanced by its aerodynamic shape and the use of advanced materials that absorb or deflect radar waves. Beyond its stealth characteristics, Taranis is equipped with sophisticated artificial intelligence and machine learning algorithms that allow it to operate autonomously. It can make complex decisions during missions, such as identifying and prioritizing targets, navigating through hostile environments, and executing pre-planned strikes. Gambit 5 is a cutting-edge unmanned aerial vehicle concept, designed to provide advanced surveillance and reconnaissance capabilities for modern military operations. This drone, developed with a focus on ISR missions, represents the future of unmanned systems with its innovative features and capabilities. The Gambit 5 is characterized by its stealthy design, high endurance, and advanced sensor suite, which together enable it to perform extended operations in hostile environments without being detected. One of the key aspects of the Gambit 5 is its integration of AI and machine learning algorithms, allowing it to process data in real time and make autonomous decisions based on mission parameters. Furthermore, the Gambit 5 is equipped with a modular payload bay that can be customized with various sensors, cameras, and electronic warfare systems, making it highly adaptable to a wide range of missions, from border patrol to deep reconnaissance in contested airspaces. The MSIDS Terrahawk Paladin is a sophisticated air defense system designed to provide comprehensive protection against various aerial threats, particularly unmanned aerial vehicles or drones. Developed by MSI Defense Systems, based in the UK, the Terrahawk Paladin represents a significant advancement in counter-drone technology, integrating multiple layers of detection, tracking, and engagement capabilities into a single platform. This system is mounted on a vehicle, allowing for rapid deployment and mobility, which is crucial for protecting both fixed and moving assets in dynamic combat environments. One of the standout features of the Terrahawk Paladin is its integration of both kinetic and non-kinetic effectors to neutralize threats. Kinetic effectors such as anti-aircraft guns or missiles physically destroy incoming drones, while non-kinetic effectors such as electronic warfare systems can jam or disrupt the drone's control signals, rendering it inoperable. Thanks for watching, and make sure to hit the like button, subscribe, and put notifications on to stay updated on everything related to AI and robotics.